Hey, so I'm going to talk to you about using SQLite as a collaborative application file format. So I think we all know we can use SQLite as a local application file format. So, backing our mobile apps or backing our web apps, even if we're using SQLite WASM build, or backing our desktop apps, and saving whatever state we need locally in a local SQLite database. But what do you do if you have built your app against SQLite and you're saving all that state locally, but now suddenly you want to collaborate? Wouldn't it be awesome if you could just flip a switch and suddenly your app that's backed by SQLite is suddenly collaborative because that SQLite DB can be synced to other users' devices or merged with other users in the changes they're making. So that's what I've been working on and what I want to show. But to rewind a bit, the story actually starts almost a decade or a little more ago, when I was working on a hobby project called strut.io. So I had started building this presentation editor, which was completely offline or local first, ran totally in the browser. There was no cloud service. And it saved everything to like local storage or IndexedDB. And it's just a quick overview. It's just the basic idea was a normal presentation editor that ran in the browser, except you could do some things like rotate and scale and reposition slides, and then give you this cool like 3D transitions. So back in its heyday, it had like 10,000 monthly active users. I abandoned the project so I could take a job at Facebook. But then, fast forward, 10 years later, I leave and I want to like resurrect this project. But the world had changed by the time I decided to resurrect this thing. People suddenly expected everything to be collaborative, right? With things like Figma and Google Docs. So I was really rabbit holing on like, how can I make this collaborative? And that's where I landed on, well, if I'm saving state locally in something like SQLite, wouldn't it be awesome if I could just make the database handle all this work? And that's what I did. So to give you a little flavor of what that looks like, I've been doing a rewrite of Strut in the framework I've been building. So the framework, if you're curious, is called CR SQLite. It stands for Convergent Replicated SQLite. It essentially lets you merge databases together, SQLite DBs together, either parts of them or them in their entirety. And the rewrite I've been working on of Strut uses this to do collaboration. So if we sign in, we just create a new deck, then let's open Safari, which is a completely different browser and isolated. We'll open the same deck. So we have two different browsers here, and now I can start adding content, and we can see it's getting synced and replicated to the other device. We can do that. We can add slides. And the cool thing, if you notice, is not every piece of state is synced, right? There's some state that's purely local only, like the guy in Safari, that user, well, they want to have their own selection state that's not tied to the user in Chrome, their selection state, that logged in user. And you can do cool interactions like dragging, typing. You can even sort slides, rearrange them. Yeah, so all great things. And all just using a SQLite DB. So yeah, I'm saying it's all just using SQLite DB. So what does that actually look like in practice? So a quick look at Strut. It's based off of a normal SQL schema, the whole data model, all the application state. So as you'd expect, you have a deck, like a slide deck, a slide, because decks have slides, and components, because, slides have components on them. And this all looks like run-of-the-mill SQL, right? Which it is. I'll get into these custom type annotations later on in the video, but you can ignore those for now, like SQL with union types. But the cool thing comes into is the tables I want to be collaborative, like the slide and the deck and the components. I upgrade them to CRRs. So technical term is conflict-free replicated relation, or just a shared replicated table that gets synced to either other peers or a server or however you have your network set up. So whatever is CRR table will be synced and shared to other people you connect with, which is what you get here. Very cool. And things that are not CRRs, such as the selected slide or the undo stack, those will not be synced. If you need to be more fine-grained, like just certain rows not being synced, you can do that as well. So you might be wondering how all this stuff works. Like, you could start with the documentation, and it explains all the different concepts of like a CRR or a collaborative table, this CR-SQL changes table. This is how you get all the changes out of a database from one database and then apply changes to a separate database. It's all done via this virtual table, altering tables, all these things, and then like React hooks and whatnot. But that's a lot of pieces to try to put together on your own. So what I have done here is created an example application that syncs over REST via manual syncing. The idea here is like, okay, like why REST and why manual sync? I think that's kind of the simplest example. And it kind of, because sync is manual, it really breaks down how the process works. So you could like open the app, you can play with it, you can make changes on different clients, and then when you're ready, you can sync and you can see how all the merging works. Whereas with the WebSocket streaming sync, which you saw with Strut, while that does exist and there are starters you can use to use that, it's harder to get a sense for how everything works. Cool. So if you go here, there's this repository that has the REST example. And I'm going to run through, how it sets up databases, how it queries, how it does sync, and so on. So inside that repository, which I've cloned down here, kind of the main thing to look for is we have this root component that kicks off our application. So first thing is there's a bunch of stuff around hash changed. So if I open, which I already have it opened, in the URL, there's a hash parameter which indicates what room we're connected to. So the idea is everybody who's connected to the same room sees all the same changes. And you can go to a different room to have a different kind of realm of pushing and pulling changes. And all this hash management stuff is just handling like, oh, if we change room names, opening a new database and syncing to a new section. But the real work happens in the root component and this DBProvider. So DBProvider opens a new database for you. And any database, right, it's going to have a schema and a database name. So right now we're setting the client database name to the same name as the room that they're using. And the schema is loaded from a SQL file that's on disk. So we have this main.sql file. And right now it just has a table called test with 3 columns. It's a CRR and it's fractionally indexed, which we'll go over a bit more later. So I can add data. I can see it here. It has that same schema, ID, content, position, ID, content, position. And a cool thing is this DBProvider that takes a schema. If your schema changes, it's smart enough to handle that schema change and handle that migration for you. Cool. So after you have a DBProvider, so you call it and you give it the component you want to render once your database is ready, in this case our app component. Inside app, there's a useDB hook, which you can use to get a handle on the database. And we'll talk about Syncer in a moment. But once you have the database, doing state updates is just a matter of normal SQL queries. So when we want to add data, we insert into that test table. We want to drop data, we delete from the test table. And if we want to see data, it's very simple too. We just have this thing called useQuery. So this is a hook that's going to subscribe us to the database and subscribe to the query we've issued. So here we're selecting everything from the table name and we're ordering it by our position, which means anytime we add data, we automatically get updated. And we didn't have to do anything special other than call useQuery. And it can be called from any component that needs to get any data from the database. Okay, and then that brings us to syncing. So use syncer. This is just the implementation that uses the REST server to push and pull changes. And the server is pretty simple. So if we go to server, we have a server TS file. And there's basically two paths, or two handlers. There's a get handler for changes room, and there's a post handler for changes room. So the get handler is to get a set of changes. And what we have in here is a couple parameters. So the schema name and schema version. So these are for if the database doesn't exist on the server, we tell the server, hey, create a new one using the schema name, and then we expect it to be the schema version. If the database is already there and it's a mismatched schema version, either an error will be returned or the client and server will be migrated to the same version. Requester, this is just the client that's requesting data, and sense. So sense is, so in SQLite, every row or every mutation increments the version of the database by 1. So anytime you want to push changes, get or pull changes, you record your last version you pushed or last version you pulled. So that way when you pull again, you can pull since your last version, and you're always pulling deltas. So back to the GET request. In the GET, we open the database for the given room with the given schema name at the given schema version. And then, if it couldn't open, we throw an error. If it could open, then we get changes. So this get changes is actually pretty simple. If we look at the docs, it's essentially selecting all the changes from SQL changes where the database version is greater than the provided version. And then we send those changes back to the client. And then for posting, this is when the client is sending changes to the server. The body has all the data. There's a decode library provided for you. WS common because it was part of the WebSocket package, but it's the same binary format. Get the data, decode the data, open the database, and then apply the changes that were received. Cool. So I think I covered most things. Covered the hooks, the useQuery, the opening a database, and then syncer. I guess I haven't shown syncing and how that actually works. So maybe I should open Safari. It's a different browser. Okay, then go to Chrome. And now it's manual sync, right? So we pull changes. Oh, we haven't pushed changes on this guy. So we push his changes, and we pull changes. And now we see we all have the same data. And apparently there's some styling artifacts in Safari. That's fine. Where our ID is, yeah, weird that the styles are different. But anyway, so yeah, and then you can play with it. You could edit some text on this side. Or here, then we can push our changes. And we can pull changes. Yeah, we see they both converge, same state. So rich text or full text CRDTs, that is in the works where you won't need to incorporate YJS or auto merge. SQLite will just understand how to merge strings of text for you. That has been in the works for a while. Anybody who's willing to collaborate, the whole algorithm is completely sketched out on exactly how to do it. It's just a matter of myself or somebody getting to actually implementing it. Let's see. And then I've shown you sorting in Strut, but here we'll do it again. Yeah, we can see that, okay, we've got the same sorting. The astute observer might wonder okay, what if you add a bunch of stuff, or let's just drop everything, just start from clean, and you add some things, he adds some things, call it ABC, X, Y, Z. We're going to push both and pull and pull. Okay. Now we see that like these guys have assigned the same fractional index to different items, right? A and X have the same position. Y and B have the same position. Z and C. So how am I going to put C between X and A since they have the same position? Well, luckily, the library handles all that for you. So let me show you that code of how that works, because it's actually pretty simple. Let's see, I think I do it in table. Yep. So when you use a fractional index in SQLite, we create this companion view. So the table was test, as you saw in main.sql, just test. But we create when you use this as ordered, you say, oh, I want to order table test by the position column. If you have special list columns, like, oh, maybe you have multiple lists in the table, you can append those there as extra arguments. Again, this is all in the documentation. But what that gives you is a nice companion view where you can actually update this view. So this view is exactly the same as the regular table, except it has this extra after underscore whatever your primary key column or columns are. So you can say update my companion view set after ID equal to whatever you're trying to insert after, and where ID whatever you're trying to move. So we just say, hey, I just want to take this and insert it after ID 83999 or 8399, and he gets moved. So very cool. And if you set after ID to null, then it just gets moved to the top. Yeah, so no like fiddling with like trying to compute fractional indices yourself. And if there are conflicts because people assign the same position to different items, the library under the hood handles fixing that up for you. And I guess the other thing is we see that this top table is shared, but there's also a concept of just like local only data. So this bottom section we can push, but there's no changes to push. So because we never upgraded this bottom table local notes to a conflict-free replicated relation, it doesn't get synced. And if you want to go more granular than that, you can actually do your own filtering. So in the syncer, yeah, so those two statements I talked about. So CR-SQL changes gives you a view of the entire database and lets you say, I want to give all changes that have ever occurred since the beginning of time or since a given version. And when you're pulling changes out, it's just normal values, right? It's like the primary key, the value, and the table that value and primary key came from, and the column it came from. So you could do your own filtering if there's certain things you don't want to send to different users. You can filter against the CR-SQL changes table. And you can even join other tables. You know, all the expressive power of SQL is there. You're not limited in any way. Cool. I think I went over everything. I think I even went over, if not, how you can add columns. And yeah, so maybe it should show that a bit faster. They're automatically, yeah, added or removed or whatever. So Automigration, you know, there's obviously caveats, right? Like there's already data here. So if we try to add foo text not null, well, you're adding a not null column to a table that already has data. Like it's just not going to add. So you need to, you know, be aware of those constraints, right? Like the table has data, the Automigrator can't add a column without a default value. So yeah, so we could add it with a default value. Yeah, so like you can just use the Automigrator. I love it for development. But there's also, you know, if you need to do, like write your own migration scripts, you can do that too. But obviously that's a headache. So the Automigrator I try to stick with as long as I can until, you know, something is really crystallized and hardened and I know the design's not going to change too much more, or I'm ready to deploy to production, then I'll start switching to like manual migrations. Yeah, I guess that brings us to like the server DB and the client DBs, right? Of like, oh, if schemas are changing, how does the server and client, stay on the same schema and ensure they could merge? So the schema file, you see it's in source schemas. So you would deploy this to your server. You'd also deploy it to your clients, and server and client will not sync unless they're on the same schema version. So this is fine. Like clients can make as many changes as they want on an old schema version. You give them a new schema version, you run the migration, and then they can sync again with the servers. Yeah. And when a client connects to a server, you can tell the server, hey, create a database if it doesn't exist with a specific schema. If the database already exists, on the server, you can refuse to create it if somebody gives you a different schema name or something. But yeah, the schema file is also on the server, right? So you'd identify it by name rather than having the client control the schema text. You just say, hey, I want the schema name. The server would say, okay, let me see if I have it. And if it does, it would just apply it. So a really cool thing that Fly.io has done is created a way to replicate SQLite databases around the world on the server side via a thing called LiteFS. So what I can do here is, so this profile is in Great Britain. Let's go to new room. This profile is where I am, East Coast US. And let's see. I actually just put this one in Australia. And it's going to take a while to load, just approximately through Australia. Okay. So what I have, maybe I should show a log too. I should do it with this profile. Yeah, okay. So we can see Sydney. We can see so I have an instance in Britain, Dulles, and Sydney. And if I add data, so if I interact from the guy in London and I push changes, we'll see that we get updates in London. And then, so we see updates in London and we see, interesting. Let's see, this should be working. Let's see if it all worked. Yeah, cool. So these guys are all connected to their specific region, and they push and pull changes to that region, and then Fly replicates all around the edge, all around the world to our different regions. So the clients in those regions can have a quick initial load time because the data has already been, the SQLite DB has already been replicated to somewhere near them. So when they first load, like it's really quick. And their round trips to the server are quicker since they're using a server nearby. So it's like a combination of strongly consistent replication on the back end across the world, and then eventually consistent replication between client and server. So like the client can go offline for indefinite periods of time, or multiple clients can concurrently write at the same time and eventually get all their updates merged back together. Cool. So the project, is, let me get out of this region so stuff's faster. Okay, the project is Vulkan. The main component for merging SQLite databases is SQLite. And all the UI integrations are in the JavaScript repository. And then the REST example. So there's a couple. There's this Vite starter, which uses if you just want to scaffold a project that uses WebSocket sync, there's the Vite starter. And then there's example REST if you want to see how that manual sync works and look into the server implementation and like see like how all that works. So it's basically two SQL statements: select from changes, insert into changes, and a little bit of error handling. So yeah, the DB wrapper on the server is like 150 lines. Pretty straightforward. So right, what's coming next? I guess one other thing I didn't show you is so all that was manual sync, right? But if you have two browser tabs, the same browser, right, same profile, just two different windows or tabs on the same page, that's automatically synced, right, as you would expect, because it's just writing to the local file system, the local browser file system, and each tab is getting notifications of that and then updating as expected. And even the local notes, right, because these are local to the user in their current session. So yeah, synced across tabs. Cool, so what's next? Right, SQLite itself is a native library, and we have tons of different releases for different platforms: Android, iOS, Linux, Windows. Then there's the JS stuff for if you want to integrate with, TypeScript, React, and Svelte, and all these things. What's coming later is more native extensions to SQLite. So right, you saw the Automigrator, you saw the fractional indexing. Next is a smarter reactive cache for SQLite. So the reactivity right now is built in this JavaScript layer. Next is going to be a native reactivity extension for SQLite. So any app that wants really high quality subscriptions to SQLite can get it. And I don't know, I think that's the coolest new thing that's coming down the pipe. I'm trying to think if there's anything else to show. Yeah, so one last thing. So SQLite, a really big design goal was to keep metadata weight a constant factor of total database size. So no matter how many changes you make while offline, no matter how many changes you make while offline, so if we keep making tons and tons of edits here to all these different fields and we push changes, I think that was a lot of changes because we had added and deleted constants. So if we make tons and tons of changes to these fields over and over again, like lots of changes, and then we push changes, we see it only turns out to be 3. Because strut was one of the first target use cases, and there's tons of interactions with dragging and spinning and typing, we needed to find a way to allow people to be offline indefinitely and build up and not have a large database size. So yeah, the backend here, the CRDTs that are used is very minimal metadata weight, which I think is super convenient for these types of applications, especially because so many people are still on low-end devices. Typed SQL is another one. So if you saw in the strut example, in the strut schema, you see there's like IID of slide, there's like in the SQL, there's union types, ID of text component, right, all these cool things. Like, okay, what the heck? Like SQLite lets you create complex types and union types. So there's a project I've been working on called TypeSQL. So let me show a quick video of that, where it's essentially making TypeScript understand SQL. So as you write your schemas, TypeScript will understand the schema and create a type for it. As you start writing queries against that schema, TypeScript will understand the shape of the results coming out and generate types for you. So this is done as a TypeScript compiler plugin. It's called a transformer plugin. And Strut makes extensive use of this to get these cool schema types. So all this is auto-generated based on that Strut schema. So the cool thing is you can even, in quotes, put in if your target is TypeScript, you can put in a specific TypeScript type that you want to model that column as. So we can see, oh, shape components, text components, they all have these opaque ID types. So now we know we'll never screw up ID types by typing them all as string. And even here, so we know we have a type of a shape component, rectangle, ellipse, triangle, n-gon, line, and so on. Yeah, it's because we put that here, and then we know when we get it out, like it's going to be a string of these types. Yeah. Cool, so I think that really is it now. Yeah, thanks for watching. Cool, so a couple more last things. There is actually a roadmap published in the CR SQLite repository under discussions. And this is kind of getting at the broader vision. It's about more than just CRDTs and collaboration and multiplayer and offline first or local first. It's also, the grand vision is changing the way we write our apps and doing it in a functional relational style, if you've ever heard those terms. And kind of the roadmap starts kind of hinting at that, right? So yes, there's more CRDT types like sequence CRDTs, counters, causal logs. So you can do, if you just want to write arbitrary mutations and do rebasing, that might be another interesting thing to show. There's a blog article about that approach where the user can write arbitrary mutations if they don't want to use a CRDT type that's defined, but I won't get into that right now. You can check that out at CRDT Substrate. Improved reactivity, and then other things like tree SQL. So this is very much just an exploration right now, but I think we can actually improve the SQL dialect to make it better for applications, right? For the application, you're not always working with data in a tabular form in your app. Like a lot of times you need it in a hierarchy or a tree. So tree SQL is massaging SQL syntax that lets you kind of write something that looks like GraphQL, but it's still SQL and still understands wheres and joins and filters and groupings and order bys and all these things. But you can orchestrate it in a pretty convenient way to say, I want a tree. So this is like, give me tracks. For each track, give me the added at and track number. Give me the album and artist, and you can start building it for the artist. Give me their ID and name, right? You start building up a tree. So this query text returns this nice JSON payload. So that's another thing we're looking at. Right, supporting sync of strongly consistent data. So yeah, a lot. If you look at linear, right, there's not much collaboration, at least historically, going on in that app. It's just kind of like, oh, you got your tickets that you're working, and you're just going to have them all synced locally, so they're all there and ready for you to start working with, so you don't have to do network round trips. And there's a lot of applications that are in that space where they don't need CRDTs or anything. They just want data prefetched and loaded and available on device, so the user doesn't have to wait to navigate between tasks or tickets or pages or whatever the heck it is. So yeah, that's another thing to start building out, have some ideas going on there. But yeah, the initial focus is CRDTs and multiplayer. Once that is buttoned up and perfectly mature, we'll start moving on to tree SQL and moving on to syncing other types of data with other consistency needs. Yeah, and then there's some smaller initiatives in the roadmap. Cool. I think that's it. See you guys. So I lied, there's actually one final thing. So yeah, I say we a lot in the video, but it's really just me doing all the things. The websites, the docs, the vision, the roadmap, replying to users. But yeah, there are a few collaborators, Braid.org, Expo.dev, Fly.io, who I'm like super thankful for like bug reports, ideas, explaining alternate ways of doing compaction of history in CRDTs or other approaches to a CRDT through like event logs and whatnot. But yeah, the day-to-day work is mostly just myself, so always looking for other collaborators or partnerships like those with Fly and Braid and Expo, and eventually Terso as well. So yeah, reach out.